Assalamualaikum warahmatullahi wabarakatuh. My name Dana Arif Lukmana. I'm an educator of mathematics education in Faculty of Education and Teacher Training in IAIN Ternate. Uh, I would say thank you for the opportunity given by the MSCEIS 2020 committee. I will present my paper entitled Geometry Problem Solving Process of Two Gifted Students with Different Cognitive Style. So, for the introductions, the research result The research results show a relationship between mathematical talents, problem-solving ability, and generalizations ability. However, very few studies currently document how gifted students perform mathematical problem-solving, abstraction, generalizing mathematical concept. Their thinking processes strongly influence student ability to solve mathematical problems. It is how students process and organize information and their cognitive activities is called cognitive style. Cognitive style is divided into two, namely field independent and field dependent. Several studies explain the relationship between cognitive style and mathematical achievement. Al-Mulhode, for example, found that the way of thinking of individual with FI cognitive style can encourage higher mathematical problem-solving performance than FD individuals. Udiono, in the results of his research, found a positive relationship between cognitive style and student achievement in the field of geometry. And furthermore, Marwazi explained the individual difference between FD and FI in solving mathematical problems using Polya steps. Discussions about giftedness in mathematics and cognitive style have been included in several previous studies. Individuals with mathematical talent show higher preferences regarding introversions, intuition, and thinking than those without talent. In addition, gifted students also tend to have higher achievement, motivations, and lower interpersonal and social problems. There is the fact that there are individuals with mathematical talents who have low math achievement in school. It means that certain variables cause giftedness not to work. Another fact is that gifted individuals do not always have the same cognitive style. So, referring to these two critical facts, I'm interested in studying how the problem-solving approach is carried out by gifted students who have different cognitive style. This is a qualitative research conducted with an exploratory method. Researchers want to explore the geometric problem solving process referring to the polyheuristic stages carried out by individuals with mathematical gifts but different cognitive style. I managed to identify seven students who have super talent in mathematics from 298 high school students. The GEFD test, consisting 25 items, was given to seven gifted students, and the results show five students were field independent and two students were field dependent. The third step in this research is giving a test in geometry problem adapted from national level math competitions. I choose two work result, one from FI individual, and one from FD individual by considering the richness of the extracted data. The fourth step is an in-depth interview guided by 21 questions to confirm each stage of problem solving, such as understanding the problem, devising the plan, and then carrying out the plan, and looking back. Data analysis was carried out on the result of the work, and interview transcript by reducing data to eliminate irrelevant data from the interviews, presenting data descriptions, and making conclusions. Here's the geometry problem instrument that I use in this research. Given a right angle trapezoid as follows. So if AB equal 1 and BD equal square root of 7 and AD equals CD, so then the area of trapezoid is blah blah blah. Okay, result and discussions. Point 1 is understanding the problem. The following describe the achievement of the problem solving indicators of two research subjects, FI and FD individuals in all stages. The table here represents several problem understanding indicators that have been identified from FI and FD individuals. The table shows that FI and FD individuals both have the same level of understanding. 7 of the 9 problem understanding items could be met except for the item analyze boundaries and unnecessary information. Both consider that boundary analysis and identifying unnecessary information was not a priority. Moreover, it doesn't mean that the facts supporting each item are the same, as when FI and FD individuals state the problem differently. FI individuals said that he can determine the area of trapezoid by the formula 1/2 times the sum of parallel side times height. So he must first find the height and length of two parallel sides. But the other hand, FD individual said that based on pictures, a trapezoid is formed from two triangle ABD and triangle BCD, two sides with the same size. So it is necessary to find the length of the side of the same triangle to calculate the area of trapezoid, because they are also the sides of the trapezoid. The second one is devising the plan. The table here represents several indicators of devising the plan that has been identified from FI and FD individuals. The table shows that FI individuals meet 8 of 9 indicators, minus zero point 0.5, while FD individuals only meet 6 of 9 indicators, minus zero point 2, 4, 5, and 9. However, both of them have different description of looking for patterns, guessing and checking, and making equations, abstracting problem, and plan solutions. Based on the interview result, it was revealed that the guesses made were different, but both led to the discovery of length of CD or AD site. The following is piece of oh, I'm sorry. And also based on the result of the interview, it was known that the two research subjects, FI and FD individuals, had different plans because their initial guesses were different. The differences in this plan lead to the same place, namely the discovery of length of the base and height of the trapezoid. Okay. The third one is carry out the plan. The table here represents several indicators of carrying out the plan that has been identified from FI and FD individuals. At the stage of executing the devising plan, FI individual and FD individual apply a settlement strategy under the plan that has been made and can explain well the meaning of symbols and manipulation of symbol use. Based on the work result, it was found that both of them didn't attempt to calculate shortcut to find solutions. FI individuals explain that they check every step of solving problems, especially calculation involving algebraic operations without using estimation and other mathematical concepts. But in contrast, FD individuals claim to be confident in the step they choose. So checking the step that had been done according to them was worth the time. What wastes the time? The following are the result of FI individuals and FD individuals work in solving geometry problem. Here are FI's work in solving geometry problem. Based on F, FI's work and the result of interview with the author, uh, the step for implementing the problem solving plan as follows. The first one is he redraw the trapezoid in the problem by adding additional information collected from the information available in problem, including assuming the length of ED and CD as x. The second point, he draw a line from A perpendicular to CD and intersect CD at point E so that line AE is parallel to BC. Hence, AB equal EC equal 1 and DE equal X minus 1 because DE equal DC minus EC. The third point, he observed triangle AED where the right angle in point E and using Pythagorean theorem to calculate AE equal the square root of 2x minus 1. The fourth point, he observed triangle BCD and used the Pythagorean theorem to find the length of BC which is BC equal square root of 7 minus x squared. The next steps, Fi individuals using a relationship between the length of AE, yeah, and BC, which is AE equal BC to find x. And then the next step, he substitute, substitute the value of x to BC, which is BC is height of trapezoid, and obtain BC equal the square root of 3. And the final step was all elements required to get the area of the trapezoid have been identified, namely the length of two parallel sides AB and CD and the height of trapezoid BZ. So the area of trapezoid was successfully found using the formula 1/2 times AB plus in bracket AB plus CD time BZ. Okay, here is FD individuals work in solving geometry. You can see that based on FD individuals work and the result of interview with researcher with me, the step for implementing the problem solving plan as follows. First of all, he identified the information that is not in the questioning, including CD equal AD, and then AB equal 1, BD is diagonal of trapezoid, where BD equal the square root of 3. The second step, FD individuals observing triangle ABD and looking for the relationship among AB, BD, and AD. The third step, FD individuals utilize use cosine rule to calculate AD, then AD square equal AB square plus BD square minus 2 times AB times BD times cosine A, where angle A equal angle BDC. The fourth step, FD individual identified that angle ABD equal angle BDC. Hence, cosine A equal cosine angle BDC equal CD over BD equal CD over square root of 7. The next step, FD individuals create an equation by combining the two equations of cosine A and substitute value of AB and BD, then using an algebraic procedures. So he found that AD equals CD equal 2. The sixth step, FD individual used the Pythagorean theorem on triangle BCD and substitute CD equal 2 and BD equal the square root of 7 to find BC equal to square root of 3. And the final steps, after successfully identified all the elements needed to calculate the area of trapezoid, such as AB and CD as two parallel sides of trapezoid, and BC as the height of trapezoid, then the area of trapezoid can be calculated. The last point is looking back. The table here represents several indicators of looking back that has been identified from FI individual and FD individuals. And also, based on the interview result, have confirmed that both FI individuals and FD individuals do not meet all the indicators at the looking back stages. Although both can justify the conclusions of the geometry problem solving results that they find, as many as 6 of the 9 indicators appear in the problem solving processes carried out by individual FIs. In contrast to individual FIs, FD individuals only fulfill 2 indicators. Neither of them could find another method to find a solution, so they could not check the result of their using other methods. Both of them cannot understand the flow of other solutions, where individual FD do not understand the flow of individual FI solutions and vice versa. What about the conclusions? The result of this study confirms that mathematically gifted students will continue to show good problem-solving skills, especially in geometry. Differences in cognitive style, file-independent or file-dependent, among gifted individuals are reflected in how many problem-solving indicators are identified. In the face of understanding the problem, individual FI and FD show the same performance. Both of them meet almost all indicators except boundary analysis. What is unique is that they can state problem from different perspectives, and even the structures and patterns defined in the problem are also different. Another fact was found in the division of the planning phase. Both FI and FD individuals cannot plan a strategy working backward, but their guises are similar. The two could find different structures, so their proposed solution path plans were also much different. Excellent performance is seen when FI and FD individuals are in the carrying out the planning phase. They can manipulate and interpret every symbol, use every symbol used, and can solve problem according to the planned solution path. Some of the important things that distinguish individual FI and FD at this phase is that individual FIs check intuitively at every step throughout the problem-solving processes. Individual FD doesn't do this. Even FI individuals can detect possible error using their estimation and mathematical knowledge. In the looking back phase, FI and FD individuals can justify the solution well. FD individuals have the high confidence in their answer, so they do not recheck whether the answer makes sense or not. It contradicts what individual FD does. The similarity between FI and FD individuals in the looking back phase is that both do not understand other problem-solving approaches, so they cannot examine the relationship between the different approaches. Thank you for the opportunity to present my paper. Assalamualaikum warahmatullahi wabarakatuh.